Alright, so finally, for the die-hard riders that want to be boosting their motorcycles. So I re-chromed the booster ends. I put the new upgraded bubbler. This is ABS here, okay, and there's been, a lot of discussion about ABS and PVC and acrylic. This here is cast 3-inch acrylic. I decided not to build the bike boosters for right now. And the reason why is because of the plate complexity. This is basically, it's still the step gap design. You got 8 individual cells in an open bath, center tapped. Okay, but here's the difference. If you look at the booster from the end, okay, these plates are custom. They're not wall plates. This is 25 thousandths stainless steel shim stock that I ordered from McMaster Car. It's custom fit to make the maximum use of the plate area. You see it fits right in there pretty tight. When I screw it in, it rubs on the sides, but I'm okay with that because this is a smaller unit. I wanted to try to compensate for the 1-inch decrease in diameter by maximizing my plate size. This is the old style 1/4 inch spacing. These are standard 1/4 inch, 1/4 stainless steel nuts, which are about 1/4 inch wide. So in order to get 8 cells to fit in there with this gapping, I had to custom form these plates and make the end ones smaller. In the flat plates, I was able to go with 1 millimeter gap. So the closer gap equates to less resistance between the open cell gaps. And at 10 amps, on a motorcycle, you can't run 20 amps. I don't know of any stock motorcycle that can push 20 amps through the alternator. Okay, so this unit runs at 10 amps. That's what I set it at, the electrolyte concentration, so that it will draw 10 amps. And at 10 amps, I am producing approximately 0.5 to 0.6 liters per minute out of this unit. And because this is shim stock, it's hard to keep straight and flat. I use a center bolt right here. This bolt helps maintain spacing so that the plates don't end up bending and touching each other. You can see the white area right there. Those are 1 millimeter washers that I insert within the cell stack to maintain spacing. This is one of the original units. It was done with a hand punch. 25 thousandths shim stock pounded with a center punch and a hammer. You can see the indentations there. So there was a little bit of warping in the plates. I was able to straighten them out, and I used 1 millimeter washers. Under here, you can see that I have a jumper. There's no bottom strap for the motorcycle booster because it's so small. That's basically the bottom strap right there. I just inserted it on the top and clamped it down with stainless steel hardware. You can see there's one clamp there that's not electrically connected to either of the posts, and then it's electrically connected to this post here. It jumps around to the other side down this strap. Okay, so basically you're connecting the outer plates to the negative or the positive, and the center plate is still connected to this terminal up here, which can be either positive or negative. Right here is a fill port, and down here I've got a drain. The chrome, it's nothing special, you guys. This chrome, it's the stuff you can get at the auto parts store. It's that adhesive chrome. It looks pretty cool. It's not perfectly flat. And sometimes it wrinkles a little bit, like right there, but you can work it out with your thumb. But that's how I get these chrome ends, because it does look good on the bike. So it's not perfect, but it looks really good. I'm happy with it. People like it. I like it. So and I do put a blue neon light behind this, although there's so much bubble action in there that you can't see the light. It doesn't show through the cell. But it still looks cool. You turn the cell off, and the whole thing glows blue, so it's pretty sick. But so that's basically this is the best coverage of the bike booster to date. I mean, I've had a few pictures. I posted a couple on the forums, but so this is kind of a more in-depth discussion on what's going on with the 3-inch motorcycle booster, 10 amps, 0.5 to 0.6 liters per minute. Always using a bubbler. Custom-made plates, 3 attachment points for stability because I'm using 25,000 shim stock. 1 mm gap. The shorted gaps are 1/4 inch. So there you go, folks. Listen, the thing I forget to mention, this is the original Smack booster. Folks, recognize this is the one. This is the trendsetter, the one that I posted the 20% increase in fuel mileage with the bike. It's made with the ABS. I don't make build with ABS anymore, but when I was out in Arizona, that's what was the material of choice because that's a geographical decision as to what material to use, and out there they use ABS. So this is the original ABS. I mean, we're going on 2 years. People that say this stuff that it doesn't hold up, I mean, I don't use ABS because it does have a lower temperature tolerance. But you know what? Even still, strapped to the side of a rumbling V-twin, 1700 cc's of, oh my God, you better hang on to the handlebars. Your ass is grass power. Okay, vibrating away in the hot Arizona sun. Man, I don't care. It gets up to 117, 120 degrees out there. All right, and I was riding the bike nonstop all the time, going to work every day. ABS, okay, cast acrylic. Here it is. It's right here. This is it. 13,000 miles. Okay, and let me show you the plates again. Original plates. 13,000 miles. It's still got electrical tape. This is the original deal, man. I don't use electrical tape anymore, but this is from way back, almost 2 years ago. So, hey guys, don't tell me it doesn't hold up, because I ain't hearing it. You understand? I ain't hearing it. But I recognize it. I mean, this is it. I told you this stuff. It will. You build it right. You build it the way I tell you to build it, and you run it the way I tell you to run it. It's gonna last the way I say it's gonna last. So here, this is the end of the argument right here. It's right here, right in front of you. Look at it. There's no stretch scratch, nothing. I mean, this is it. So, all right, original Smack booster, the original, still running, still going strong. When I'm done with doing the tank and the tins, all that stuff on Thundernutz, and I get this thing back on, making a new bracket for it, it's a little better than the old one. It will continue to go. We'll still be putting miles on this thing. I'm going to take it to bike shows and whatnot. The original Smack right here. So folks, recognize. Hey, Smack! Ha Yes, it's done. So finally, I've got the painting and the fabricating and all the mods done that I was working on this spring on the Thundernutz bike. This is my 2004 Yamaha Roadstar Warrior, and what I'm doing today is discussing the booster installation. This is the original Smack, the original design, where I first began posting my 20% increase in fuel mileage. This is the standard, the benchmark to be reached by all replicators. The first thing I want to discuss is the routing of the hydroxy gas from the booster, the path that it takes from the booster to the engine. So first, obviously, like any other Smack, the gas comes out of the top of the unit, through the check valve, up through the bubbler, out the top of the bubbler, and now this is where things become a little different than from your standard automobile application. You see the hose here goes up to this plastic Y right here, and the reason why is because I have 2 throttle bodies. This is a fuel injected application, and I have 2 throttle bodies, and I have also gotten rid of the stock airbox. Okay, so instead of an airbox, I have 2 K&N unifilters. Now, with those of you, most of you have an airbox on your bike where you have 1 air filter, and you can do your installation on your bike the same that you would on a car. Introduce the hydroxy output tube in front of the air filter element, let the gas diffuse through the air filter element, and then go on down through the throttle bodies. In this case, there is no airbox, so what I've done is I have been forced to utilize this Y connection, and then to each separate throttle body, I've routed its own unique line. Here's the one to the right hand side. There's a hole that I drilled right in the bottom of the unifilter and poked an elbow through it. And on the other one, and you can see it a little bit better from this angle, this is the left hand side. Okay, So you get an equal distribution of hydroxy gas to both of the throttle bodies. Now, one important thing to mention when you're doing this kind of application, because some of you guys are going to be set up this way, okay? You see how the tubes are angled down? They're not straight across, no low points, no loops, okay? Just about every hydroxy generator that I know of does emit some amount of water condensate out of the output of the unit. So if you have, in this case, when you have if you have one line, that's not a problem. You get some water in the line. The gas will push through. Eventually, some of the water will be ingested into the engine. In this case, when I have a Y with two separate lines coming out, if one of these lines gets clogged with water and the other doesn't, what you have is one cylinder getting 100% of the hydroxy output and the other cylinder getting nothing. And that you create yourself an unbalanced condition. Obviously not ideal, not efficient, and possibly could be dangerous to the health of your engine. So you'll see that there is no place for water to build up and clog the lines, forcing the gas to go to the opposite line. Both are down, angled down, therefore they drain back down into the bubbler if there is any condensate. Okay, so that's the gas routing. And as far as, don't worry about these guys here. These are for the neons. Yeah, the neons. That's right. The Smack rolls in style. This whole engine goes purple at night. But that's for another story. I do want to mention, as far as the engine management system goes, once I got this system installed, I did take it to a dyno shop, and I had them hook it up to their dyno, and they monitored engine conditions, and they did adjust. I'm running a power commander back here. This is a power commander in which I can download different fuel maps for different configurations that I run on the bike. It's all, it's kind of a plug and play deal where I can modify my fuel mix and various other parameters on the fly, so which is really kind of helpful in this situation because I can mess around with engine parameters freely at will, and not it's not really difficult. All I got to do is plug my laptop in. Is exhaust gas temperature reading 1,160 degrees Fahrenheit. My Power Commander 3 USB interface and my laptop interfacing with the Power Commander with cylinder trim function. What I've just done is I have richened up. This is rich. This is lean on the front cylinder. The front cylinder is where I have the exhaust gas temperature gauge hooked up. And I'm going to show you a swing in exhaust gas temperature right now. What I've done is I've richened it up to the maximum, okay, to achieve the 116 degree 1,160 degree Fahrenheit exhaust gas temperature reading. And now what I'm going to do is I'm going to lean the mixture out all the way to the maximum, and what we're going to see is the exhaust gas temperature rise from 1,160 Fahrenheit, and it's probably going to go up well above 1,200. So let's check it out. When I hit OK, this will download this leaner fuel trim setting to the Power Commander, and the Power Commander will tell the bike to run the front cylinder leaner, and we'll see that on the exhaust gas temperature gauge. Okay, so here we go. Let's send that data. All right, up to 117, 118. Temperature rising there. And effectively what I'm demonstrating to you is when you lean out air-fuel ratio, you raise your exhaust gas temperatures. And here's the proof right here. For those that say that adjusting air-fuel ratio doesn't affect exhaust gas temperature, or some have said that leaning the air-fuel ratio lowers the exhaust gas temperature, this right here is proof that leaning out the air-fuel ratio raises exhaust gas temperature. So we're up to 1200 Fahrenheit at idle here. And this gauge ported right there at the exhaust port of the front cylinder, which in this case this is number 2 and this is number 1. Okay, so we're at 1200 or so Fahrenheit exhaust gas temperature. Okay, let's see if we can. We'll go back to the trim function, and what I'll do is I will richen that mixture back up again. Okay, now let's see what happens to those exhaust gas temperatures. Oh, we're already down to 119. So I've richened the mixture. You saw me move the slide bar to the positive percentile, which means richening. Okay. So our exhaust gas temperatures are lowering again. Takes a while for it to cool off, obviously. But as you can see, we are slowly cooling off again. See if we can get it back down to 116. I'll shut her down. Now, this video demonstrates the importance of having an exhaust gas temperature gauge on the application, on the vehicle that you're attempting to install a hydrogen booster on. Okay? You must understand and be able to tune your engine. You can't just throw one of these things on and expect them to work properly. You have to tune the engine accordingly. Alright, so like I said, it takes a while for it to cool off. Give it a couple more seconds and we'll shut her down if she doesn't hit 116. Not going to go back down there, but you do see the you have seen the temperature swing. So, all right, going to go ahead and shut that down. Okay, now what I've just proven to you, or what I've just demonstrated to you, is the importance of being able to tune and adjust your application. I want to show you what motivated me to do this. I was performing an oil change and a tune-up on the Thundernutz bike. The Thundernutz bike! Yeah! What's up? Recognize. You can see by looking at the plugs, this was the front cylinder, this is the rear cylinder. You can see there is an imbalance between the front and the rear cylinders, 2 plugs per cylinder. This one's running a little bit richer than this one. Okay, so I wanted to trim back on the air-fuel ratio on the rear cylinder to get these to match, so they're running a little bit closer. Okay, and that's what motivated me to go ahead and run these cylinder trim value tests. Okay, so this also gives me an opportunity to discuss a little bit with you this fuel map that I had developed for the Thundernutz bike with the hydrogen booster application. Okay. And showing the importance of being able to use your equipment and gauges to properly tune your application. Okay, so this map was custom made at a dyno by a motorcycle technician. Okay, and what we have here is throttle position and engine RPM. Okay, and each of these blocks, each of these numbers represents a fuel mixture value. Okay, so basically what the technician did was go through on the dyno all the various conditions one by one by turning the throttle and adjusting load and changing RPM. Went through and adjusted all these values to get the proper air-fuel ratio, and he measured that, and he had a gauge at the exhaust pipe and an interface with the power commander. Okay, so he was able to go through and custom make this map for me, okay, in my application. When you lean your air-fuel ratio, as I have just shown you on that exhaust gas temperature gauge, when you lean, you raise temperature. When you raise temperature, because NOx, nitrides of oxygen, are formed at higher combustion temperatures, you raise your NOx emissions. So it's very important that you not overlean using your FE device. This here is comparable, not as fancy, but it's comparable to installing an FE device to interface with your ECM to adjust your O2 sensor signal. This is comparable to that, basically doing the same thing, except I don't have an O2 sensor on this bike. It's all done by this fuel map, but the result essentially is the same. You're changing your air-fuel ratio. Okay, when you're hydrogen boosting, as you've seen in my genset videos, you lower exhaust gas temperature, and that enables you to lean the fuel mixture out to put the exhaust gas temperature back where it was originally. Okay, that's why you need an exhaust gas temperature gauge, and that's why you need a method of adjusting your air-fuel ratio. Otherwise, you'll put a hydrogen booster on your application, and there's probably a 70 to 80% chance you will not see an increase. And that was demonstrated in the genset videos, and how to do that here I've just shown you. This is one method when you're using this kind of a fuel management system. Every application is different, so you need to know your application. This is not plug and play. You guys need to learn and know how to tune your applications for if you want to see results. So I did have them go through the various RPM bands and tune the engine to, of course, I got tons of custom stuff. You got the Barron's Big Air Kit, you got the Samson ground pounders, and all kind AIS delete, all this stuff changes the way the engine runs. So I have a custom fuel map on this bike, which was mapped with the booster running. So, and also I verified that the map was proper by doing a couple of things, and this should be standard on any vehicle that you decide to install a smack booster on. You need to have two basic components to monitor the performance of your engine after boosting. You either need an air-fuel ratio gauge, a cylinder head temperature gauge, or an exhaust gas temperature gauge. Okay, these gauges are essential. Now, the Smacksmobile has an air-fuel ratio gauge. I prefer the EGT. This bike is done right. I started, from the ground up, doing everything in the best manner possible. So I chose an EGT gauge, and I myself installed it. It didn't come with one, obviously. So the sensor is right down there. It's routed up, through the wiring harness, fished up through the handlebars, to the custom RLNS gauge pod. Okay, and that monitors my exhaust gas temperature coming out of the forwardmost cylinder. So, with this gauge in place, I was able to get a baseline of the gas temperature under normal operating conditions without a booster. Then when I installed the booster, okay, I was able to compare the readings and verify whether or not I had changed the running condition significantly. Did I make it too lean? Did I make it too rich? So this is a safety assurance device for me to let me know whether or not I'm potentially damaging my engine. So with the custom fuel map done, and by the way, this bike has no mass airflow. It doesn't have an O2 sensor. It's all done off custom fuel maps, which, like I said, I prefer it better because you can custom tune it. The other important gauge, and the Smacksmobile does have one of these, but obviously it's not half as nice as these 6 sweet digital gauges, is your current gauge. And this is the running current for the Smack booster unit. And set up cold right now, we're running 4 amps. That's 4 amps cold, and heated up, she'll be running at about 10 amps. Okay, so right now it's putting out about 1/4 liter per minute. Once it gets up to about 10 amps, it's putting out about 1/2 to 0.6 liters per minute. Okay, and the reason why and you can see the cool purple neons, by the way, and there's one to backlight the booster too. Yeah, that's right, it's sick, totally sick. So basically, the bike's electrical system can't handle more than an extra 10 amp current draw. It's just too hard on the alternator brushes. The battery, I've had the original battery in this bike since I bought it, so that's going on about 2 years or so. Okay, and it's starting to take it kind of hard. It's still the same battery, but it's time for a change. The extra 10 amp draw on it, and plus I've got 1 or 2 amps for the neons going during the night. It's getting tired, and it's getting to the point now where if I go anything over 10 amps, the bike just won't restart. So it's time for a new battery. But you guys who run a lot of power accessories on your vehicles know that when you increase power load, you're going to have to beef up the electrical system, and you're going to have to expect some more wear and tear, higher frequency replacing your battery, so on and so forth. So I knew that was coming when I did this upgrade, and to be honest with you, it's worth the cost. I'm due for a new battery now, but hey, guess what? I'll live with it. It's worth the 20% that I see on the bike. I get an extra 20 miles out of the tank. So, it's worth it to me. So, I also want to go over, the typical Smack protocol, solder and shrink wrap, all electrical connection, 18,222 miles on this bike. Okay, 13,000 of those miles were put on with this exact booster. Okay, you don't see any melted posts. Okay, you don't see any cracked ABS. These things do hold up, and the proof is right here. So, okay, so those are the basics of Smack booster installation on a motorcycle. Okay, you need to be aware that you need to monitor your booster current. It's a real good idea to monitor engine temperature via one of the methods that I discussed. Okay, you want a good, robust mounting bracket. You can see the top. There's the bracket behind the booster there, and there's a bar that runs down the back side of it. Okay, and just like on the Smacksmobile, okay, I built myself a nice little cradle. You can see, nice little cradle for it. And there's another bolt down there in the bottom. So it's a two bolt mounting system. Okay, it's real solid. I could just push on this thing, and the whole bike would fall over and not break the booster, and break the bike, but it wouldn't break the booster. This thing is on there. Okay, so you know what? I know some of you guys are looking at this going, man, I don't have a welder. I don't have the equipment or the knowledge to build a bracket like this. How can I? I can't. How can I? Hey, listen. Jesse James I love Monster Garage, and he's one of my all-time favorite fabricators. And you know what? He's a hero of mine. All right. And one thing he was always used to say to people who were unsure of their skills, he's like, you got to go out there and do it. Don't question yourself. If I can do it, you can do it. You just got to grab a tool, grab some metal, and just go for it. Put some metal in a vise. Borrow your buddy's 110 MIG welder and try. Just start building stuff. If I can do it, you can do it. So don't tell yourself, oh, it's too hard, it's too complicated. Man, you can do this stuff. If I can do it, you can do it. All right, that's a Smack axiom right there. If the Smack can do it, you can do it. Because you know what? I may be smart, I may be skilled, but I'm just a human being, and I'm really nothing special. I don't possess any capabilities that any other one of you people also possess. So, go out there and build it, man. You can do it. All you got to do is be shown how. And so I'm showing you. This is it. This is how you do it. This is the original Smack, given the 20%. And dude, look at that thing. It looks sick, right? And it works. And not only does it work, but I've established a method a way of monitoring its performance so that I can stay on top of it, so that it doesn't damage my engine, and I know what's going on with it. It's just a matter of being thorough, being precise, being persistent, and not giving up. I mean, this design didn't come about overnight. This is 2 years worth of hard work. Tons and tons and tons of reading. You guys, I mean, you can't even imagine the amount of hours. Well, some of you can imagine, because some of you are doing it right now. You're getting up to speed. You're doing the right thing. Get up to speed. Study. Read up on this stuff. And you know what? The best thing you can do is build a smack. I mean, there's a lot of designs out there, but this is the most achievable for you beginners. Build a smack and use it. Test it. Make it work. So, okay? So listen. That's what's going on. Lots of questions. Everyone wants to know, man, what's up with the bike? Okay? That's up with the bike. This is what's up. This is what's going down. Recognize, all right? This is the infamous Thundernutz. Okay? Tearing up the streets, saving money, 20% increase, hybrid motorcycle. Okay? So we got the booster cranked up. So do you want to hear it run? I know, there's no gas tank on it. I know you want to hear it run. Yep. Don't even tell me you don't want to hear it run. All right. Let's crank it up. Let's crank it up real shit. There should be enough gas in it. Yeah. Yeah, that's how we do it in Smack's Garage, fools. Recognize. And remember, if I can do it,